Hi everyone, in this video we look at a question where we're told the average depth of the water at the end of a dock is 6 feet. We're told this varies 2 feet in both directions with the tide, and we're told suppose there is a high tide at 4 a.m. If the tide goes from low to high every 6 hours sinusoidally, write a trigonometric function d of t describing the depth of the water as a function of time, with t is equal to 4 corresponding to 4 a.m. And then the second part of this, we're going to find all times in a 24-hour period when the depth of the water is 5 feet. So the first part of this question, we have to come up with information to write a sinusoidal function for this situation. So the first thing that we're going to do is we're going to pick the low-hanging fruit, and we're going to figure out what the amplitude is. So the amplitude is equivalent to the maximum minus the minimum divided by 2. So the maximum depth minus the minimum depth divided by 2, which is equal to, the maximum depth is going to be 8 feet because the average depth is 6 feet, and we're going up 2 feet from 6 feet, which is 8 feet. And the minimum depth is going to be 4 feet, so we're going to have the max is 8 feet, and the minimum is 4 feet. So we've got 8 minus 4 over 2, which, no surprise, is 2 feet. And you can pretty much tell what the amplitude is just by reading this question. You actually don't need to do this calculation, because here you can tell right away. It says this varies 2 feet in both directions. So that means that the amplitude is going to be 2 feet because the maximum is going to be 2 feet above the average water depth in this problem. So you really don't need to perform this calculation. We could have trivially said that the amplitude is 2 feet. The next part of this problem is we are going to think about, we need to think about what the period is. The period is going to be, let's see here. It says the tide goes from high to low every 6 hours sinusoidally. So if we have a sinusoid, if we sketch out a sinusoid like this, we're going from high to low every 6 hours. So if this is 6 hours, remember that a sinusoid is broken up into quarters. So that means if this distance is 6 hours, then this distance has to be 3 hours, and this has to be 3 hours as well. So that means that in order to complete the complete cycle is 12 hours, and thus the period would be 12 hours. So the period is equal to 12 hours. Our K value is going to be equal to 360 degrees divided by 12 hours, which is equivalent to, well, let's see, 360 divided by 12 is 30, so we have 30 degrees per hour. Okay, the next part, so we have our K value, our period, we know what the amplitude is. Since we're told the average depth of the water at the end of the dock is 6 feet, we know that C is going to be equivalent to 6 feet. And that's the equation of the axis. So our equation of the axis is y is equal to 6. The last piece of information that we have to figure out is, well, we need to figure out whether we're going to model this using a cosine curve or a sine curve. And then we also have to determine whether we're going to have a phase shift for our sinusoidal function. So normally, for the cosine curve, we have a maximum occurring when we have a peak occurring along the vertical axis. Here, the peak occurs at a time of 4 a.m., which is 12 hours, or sorry, which is 4 hours past midnight. Okay, so we're 4 hours past midnight. So that means that we're going to have a phase shift here if we use the cosine curve of 4 hours. So D is going to be equivalent to 4 hours. And we're going to use a cosine curve to model this because we've shifted this. Normally the cosine curve would look something like this, where we have a maximum we would have something like that, where we normally have our maximum occurring along the vertical axis, but here we have this maximum occurring at when t is equal to 4. So we have a phase shift of 4 units to the right. That's why d is equivalent to 4. So, and we could have actually used a sine function to model this as well. It's just easier to use a cosine curve here because we can see exactly where the maximum shifts horizontally to in this problem. But you could have just as easily used a sine curve as well. Oh, whoops. So the last thing that we need to do is we just need to write the equation. So we can say, sorry guys, just a second here. Therefore, the equation d of t is equal to 2 times the cosine of 30 times t minus 4 plus 6. Okay, so that's the first part of this question. The second part of this question, we're told find all times in a 24-hour period when the depth of the water is 5 feet. So what we can do here is we can let d of t. So when the depth of the water is 5 feet, d of t is going to be equal to 5. So let d of t be equal to 5, and then we've got 5 is equal to 2 times the cosine of 30 times t minus 4 plus 6. And now I can solve this equation. If I solve this equation, I first subtract 6 from both sides, and I have negative 1 is equal to 2 cosine of 30 times t minus 4. I can divide both sides by 2, and I get negative 1/2 is equal to cosine of 30 times t minus 4. And I can think about when, if I think about when is cosine of theta, equivalent to negative 1/2? And to do this, I'm going to just think about my unit circle. Cosine is negative. Let me just try to sketch out a circle as well as I can here. Okay, good enough. Not really circular, but it'll do. Cosine is negative both in the second and the third quadrants here. So this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So cosine is negative in quadrant 2 and quadrant 3. And now let's think about what the angle is. The related angle is 60 degrees. So that, or the reference angle is 60 degrees. So that means this angle is 60 degrees. And we could have the terminal arm being located in quadrant 3 as well. So this angle could be 60 degrees. So that means that theta is either going to be equal to 120 degrees, or theta could be equal to, and this is just between 0 and 360, by the way. So we have theta could be equal to 120 degrees, or theta could be equal to 180 plus 60, which is 240 degrees. So in a single revolution, theta could be equal to 120 degrees, or theta could be equal to 240 degrees. So that means that there's two values for 30 times t minus 4 in a single revolution that satisfy this equation. We have that 30 times t minus 4 could be equal to 120, or 30 times t minus 4 could be equal to 240. And this is over a single cycle. So if we solve this equation, we get t minus 4. We can divide both sides by 30. We have t minus 4 is equal to 120 divided by 30. 120 divided by 30 is just 4. So we get that t is equal to 8 a.m. If we solve this equation, we get that 30 times, we divide both sides by 30. We get that t minus 4 is equal to 240 divided by 30, which is 8. And so t is equal to 12. So what that means is that we have the depth of the water is 5 feet at 8 a.m. and 12 p.m. So remember that t is equal to 0 corresponds to midnight, so 12 hours past that would be 12 p.m. Okay, so let's think about this. So over a 24-hour period, we get 2 points in the single cycle when the depth of the water is 5 feet. But it says in a 24-hour period. Now, in a 24-hour period, there's 2 cycles of this function, because the period of this function is actually 12 hours. So that means that 12 hours after 8 a.m., we're going to have another, or we're going to reach a depth of 5 feet again, and 12 hours after 12, I guess this would be 12 p.m., we're going to reach 5 feet again. So therefore, the depth of the water is 5 feet at 8 a.m., 8 p.m., because 12 hours after 8 a.m. is 8 p.m., 12 p.m., which is what we solve for here, and 12 a.m., since 12 a.m. is 12 hours after 12 p.m. Now, the reason that we get the same depth when we add the period is because remember that when you add the period to a given when you add the period to a given time, you're going to get the same value of this function repeating itself, and that's based on the definition of a periodic function. So that concludes this video, and we'll see you in the next lesson.